Ever see rust on a piece of metal you've left out? Well, that's the type of composition reaction. If you have no idea what I just said, don't worry, because we're going to be explaining each type of reaction to you in less than 5 minutes. Hi, my name is Caden, and if you found this video helpful, please consider hitting the like and subscribe button to help us out. 1. Composition reactions. Now, just like the name suggests, composition reactions are reactions that yield one product from more than one reactant. Now, for simplicity's sake, all of the metals that I'm going to be using will form a 1+ charge, and all the non-metals that I'll be using will form a 1- charge. So now let's take a look at table salt, for example. We have sodium plus chlorine gives us sodium chloride. Now that's a skeleton equation for the reaction of table salt, the one we eat. Now the reason why chlorine has a subscript of 2 in the reaction is because it is diatomic, meaning that it exists as a pair in nature. Now there are 7 elements including chlorine that are diatomic. You have hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. Back to the skeleton equation. All we have to do now is balance. So we make sure that we have equal atoms of each element on each side. So we have 2 chlorines on the left side and 1 chlorine on the right side. So I'm going to put a coefficient of 2 behind the sodium chloride, and that number gets distributed to each of the elements. So now I should have 2 chlorines in total. Now that my chlorines are balanced, I have 2 sodiums on the right side and 1 sodium on the left side. So I'm going to add a coefficient of 2 behind the sodium on the left side, and there we go. We should have our balanced equation of 2 sodiums plus a diatomic chlorine gives us 2 sodium chlorides. 2. Decomposition reactions. Now, unlike the composition reactions, the reactant usually breaks down into multiple products. Let's take a look at the table salt example. We have sodium chloride breaks down into sodium and chlorine. That's the skeleton equation for the decomposition reaction. Now balance this equation like we did for the composition reaction, and we should get 2 sodium chlorides breaks down into 2 sodiums and a diatomic chlorine. Now I challenge you to write a decomposition for water. 3. Single replacement reactions. Now this reaction occurs between an element and a compound. Now in these reactions, it is key to remember that only metals replace metals and non-metals replace non-metals. Now another tool that I'm going to introduce to you is called an activity series. Basically, only a more reactive metal can replace the original metal in the compound, or else we would deem it to have no reaction. Let me show you. Let's take a look at this example where potassium reacts with sodium chloride. So potassium is a metal in group 1, the same group or column as sodium. Now since they are both metals, let's see if we can replace them using the activity series. Since potassium is higher than sodium, potassium can kick the sodium out and take its place in the compound. We're left with the final equation or reaction of potassium plus sodium chloride when reacted gives us sodium plus potassium chloride. Normally we would have to balance the equation, but this one's already balanced for us. Lucky us. 4. Double replacement reactions. Now these reactions occur when 2 compounds switch metals or non-metals, doesn't really matter, to make 2 new compounds. For example, let's take a look at potassium fluoride reacting with sodium chloride to make potassium chloride and sodium fluoride. Notice how they just switch partners. That is basically a double replacement reaction. Now remember, for simplicity, I only use metals that form a 1+ charge and non-metals that form a 1- charge. Alright, that'll be it for this video, and if you found this video helpful, please consider hitting like and subscribe. We also launched our new Discord server, which I will link right below, where you can ask questions and get individualized response and tutorial from our team within a day. We still offer free group tutoring for more individualized support at biorithmetic.com/tutoring, and I hope to see you there. Until next time, see you later.